Welcome learners in the series of videos on Python programming. We are writing the Python programs for various matrix operations. We already written the programs for adjoint of a matrix or the determinant of a matrix. In the previous video, we have written a program for how to generate a identity matrix. Now today, let's talk about Cramer's rule. Cramer's rule. So basically, we will write a 2 by 2 program to get the solution of a system of two equations in two unknowns by using Cramer's rule. So before going for the programming, let's talk about this Cramer's rule. Okay, let us take a specific example here. Let us take a system of two equations in two unknowns, linear equations. So for example, let us take 2x plus 4y equals to 3, and another let us take 6x plus 7y is equals to 2. Let us consider these two equations. Now to solve this system of equation means you need to find the value of x and y which will satisfy both the equations. As we already know, one of the method to get the solution of this is like the method of elimination, right? You make the coefficients equal, add, subtract, and get the value of the other variable. Okay, now what we are going to do is we are using this Cramer's rule. Okay, so let me first write what is Cramer's rule here. Now let us write a 2 by 2 matrix first. So if we have 2 by 2 matrix, say 2 by 2 system of equations, say a1x plus a2y, say b1y is equals to c1, and a2x plus b2y is equals to c2. So let us take two equations, two unknowns, where a1 b1 c1, a2 b2 c2 are constants like this. Okay, and we need to find the value of x and y which will satisfy this. Again, remember, the solution what we get need not be an integer. You may have a fraction there, right? So we need to incorporate float function in that. Now what it says is, first, this system can be written in the form ax is equals to b. Okay, where our a will be a matrix like this, coefficient matrix. It is a1 b1 a2 b2. Okay, this x is a column vector wherein we have x and y, right? Let us set capital x and y, and this b is again a column vector which is nothing but c1 c2, and this is a matrix equation. This is matrix equation. In fact, there is a rich theory of system of equations. We can have another video on this, but today our aim is to go for the Cramer's rule. So let's discuss only this Cramer's rule. Now this, when you multiply, you will get the system like a1 x plus b1 y. You will have this matrix that is equals to c1. So two matrices are same provided their corresponding entries are same, and of course they should have a same order, right? So you'll get these equations. Now what this rule says, you first get the determinant of a. Find the value of the determinant of a. If determinant of a is not equals to 0, then we can use Cramer's rule. And this Cramer's rule, directly we will get the values of x and y. X is given by determinant of x is the first variable, first unknown variable here. So what you do is you replace the first column by b. So the first column becomes c1 c2. So it is c1 c2, and keep the second column as it is. So b1 b2, and when you find this will be c1 b2 minus b1 c2, and not only this is divided by the determinant of a. So in that case, your determinant of a will be a1 b1 a2 b2, And when we get the value of this determinant, this is let us write here, this is equals to a1 b2 a1 b2 minus a2 b1. This is the value of x, and to get the value of y, again we replace the second column now. So the first column as it is a1 a2, the second column which is b1 b2 is replaced by c1 c2, those coefficients on the right hand side, and of course divided by the determinant of a, and in this case it will be a1 a2 b1 b2. And when we expand this, this will be a1 c2 minus a2 c1 divided by a1 b2 minus a2 b1. So directly we will get the value of x and y. And since we are dividing by the determinant, the condition that determinant of a is not equals to 0 is important there. Okay. Now let us apply this Cramers rule for this system, and then we will write the Python program. If you don't want to see this how it works, you can directly jump up for the program. Alright. So for some viewers, let us solve this equation, two equations, two unknowns, by using Cramers rule. So our system was 2x plus 4y equals to 3 and 6x plus 7y is equals to 2. So let us write that first. 2x plus 4y is equals to 3, and other was 6x plus 7y equals to 2. Okay. In this case, we can write a, or let us write this in a matrix form. This will be equals to 2, 4, 6, 7 into x, y equals to 3 and 2. In this case, our value of a, the matrix A, is nothing but 2, 4, 6, 7. This is the value of a, the coefficient matrix. The matrix X, which is unknown coefficient, unknown variables there, it is xy, and the matrix B in this case is 3 and 2. Okay. So first we need to find the determinant of a. Determinant of a becomes determinant of 2, 4, 6, 7. This is 2 into 7 is 14 minus 6 into 4 is 24, and this determinant becomes minus 10, which is not equals to 0. And since it is not equals to 0, we can find the solution of this by using Cramers rule. Okay. Now Cramers rule says by using the formula, we can get the value of x, the first variable. How? We can get it by replacing the first column by the b vector. So the first column becomes 3, 2, and the second column as it is 4, 7, divided by, we will get a determinant of a, that is what the formula says, determinant of a. Right? Let us not write all this because we already calculated it. So this is equals to 3 into 7 is 21 minus 8 divided by determinant of a, we got minus 10, and this is nothing but 13 upon minus 10. Right? So this is the value of x. Similarly, we can get the value of y. The value of y is given by the determinant of first column as it is, so 2, 6, 2, 6, and the second column is replaced by 3, 2. 3, 2 divided by, again, the determinant of some matrix which we have already calculated, that is determinant of it. This is 2 into 2, 4, minus 6 into 3 is 18, divided by, we got minus 10, and in this case we will get this as minus 14 divided by minus 10. When you replace this, we will get this as minus minus becomes plus 7 upon 5. Hence we get, therefore we get x equals to, if I am not wrong, this is 7 upon 5, is it? No, x is 13 by minus 10, x is 13 upon minus 10, and y is 7 upon 5. Right? Let us verify now. Verification. So let us see whether whatever solution we have got, does it really satisfy the given equations. Let us take the first equation. The first equation is 2x. First equation is 2x plus 4y is equals to 3. This is we have to verify. Okay. How to verify? We will put x and y as these values and check whether we are getting 3. So left hand side becomes 2 into x, x is 13 by minus 10 plus y, sorry 4, y is 7 upon 5. This becomes cancels out, we will get minus 13 upon 5, and this becomes 7 into 4, 28 upon 5, and this becomes 28 minus 13, it is 15 upon 5, that is equals to 3. That is our right hand side of the first equation. Likewise, we can verify the second equation as well, and we can see that this is the solution of the system of equation. This is the solution of this system of equation. Okay, the same rule can be applied for any n by n, the system of n equations in n unknowns. Okay, for example, if you take 3 equations in 3 unknowns, you will get A as 3 by 3 matrix, X as a column vector x y z, B as a column vector say c1 c2 c3. Okay, now to get the value of x, the first variable, we will replace the first column by B matrix, where this column vector B, and divided by determinant of A. The same method applies for any n number of equations, n unknowns, but very important condition, it is nothing but the determinant of A should not be equals to 0. Okay, so right now we will write a Python program for solving two systems in two unknowns by using this formula. Right? So we will find the value of the determinant first. We will first ask the user to enter the coefficients. Let us denote this by a1, b1, c1, a2, b2, c2. We will take those coefficients as a float because we don't know whether the solution will be integer or not. It may not have a integer solution. Then we will display this system to the user, and by doing the calculation that the determinant of A and the formula for x by using this and y for this and this, we will calculate this and we will print the solution to the user. Okay, so this is all about today's thing. So let's start the program now. So this is the program for Cramers rule. Okay, as I said, we will tell the user to enter the system. Okay, so let us print first. Print command enter. We will tell the user to enter the coefficients. Enter the coefficients of the coefficients in the following format, because the user might not know how to put the this one. Okay, so because this is our system, we assume that a1, b1 and c1 are the coefficients of the first equation, and a2, b2, c2 are the coefficients of the second equations. So let us tell the user that you have to enter the coefficients in this fashion. So let us print that. Print. Let us print the equation in that fashion. We will write a1 directly. Okay, so a1 into x plus b1 into y is equals to c1. That is our first equation, and let us write the second equation in the next line. Print a2x plus b2y equals to c2. Okay, let's compile this. We will see how it goes there. First, let us save this in Python programs, music, edit in documents, and then Python programs. This roll number 16, state 16, Cramers. So enter the coefficients in the following format. a1x plus b1y is equals to c1, a2x plus b2y is equals to c2. Apart from this, we are not given anything. We just told the program to print this values. So now let us take the inputs from the user. Okay, and as I said, we will take the inputs from the user as a floats. Okay, so let us take a1 equals to, let us take float input is input from the user, and we will tell the user to enter a1. Okay, so when whatever value the user will put for this enter a1 value, that will be stored in a1. Okay, similarly we will tell the user to put the values of other ones. So let me just copy and paste. We will have 1 2 3 4 5 6 values. So let me paste this 6 times. So a1 is 3 4 5 and 6. Okay, and this is b1, this is b1. That's to reduce our work of these things. c1, this is c1, this is a2, this will be b2, and this is c2. Right, so a1, b1 and c1 are the coefficients of the first equation, and a2, b2, c2 are the coefficients of the second equation. Okay, now let us tell the user that whatever equations, whatever the values the user has given, its values, the equations will be looking like that. So let us tell the user that the entered equation is like this. So print the equations entered are, okay, and then we will print the equations. Now while printing the equations, we have to be careful because we need to code the values. So print we can put x, but this a1 value will be coming from the user, so it will be a1, not in the comment, a1 comma, then we write the value of x. So let us put this colons x plus, plus, close this, b1 again, this y in the comment, y, then we have equals to here's the comment, c1. Right, and similarly we will have a2x plus b2y is equals to c2. Let me just copy this. This is a2, a2, this is a2, and we will make this c2. Let us compile, print, enter the coefficients in the following format, that is a1x plus b1y is equals to c1. So let us take a1 to be, say, same equations we will take, say 2, okay, so the same equations we will take, say 2, a1 is 2, and then it was 4, and then it was 3, and second equation was 6, 7, 2. The entered equations are 2.0x plus 4.0y is equals to 3.0, 6.0x plus 7.0y plus 8.0, sorry, 2.0. Now these point zeros are coming because we have taken this inputs as a float. If you take this as a integer inputs, then we will not get that zero zeros. Okay. Now let us do the calculation part. Let's go for the calculation part. Now for calculation part, we will use the same equations. This equations directly, right? And I will use it as exercise to give the general formula. So write the program to get the general formula for that. So we have printed. Now let us go for the printing. When the determinant of this matrix is 0, we said that we cannot use the Cramers rule, right? We cannot, solution does not exist. Okay, so let us first print, or let us this we have printed already. Yeah, two equations we already printed. So if the determinant, and how is the determinant? Determinant is, how is the determinant? Determinant is a1 b2 minus a2 b1. So if a1 into b2 minus a2 into b1 equals 0, print the determinant of the coefficient matrix is 0. Cramers rule cannot be applied. Okay. If not, then we write else we calculate x and y. Else x equals to, we will calculate what is x and y. So x equals to the denominator, this one divided by the denominator, and for denominator we have this coefficients of this determinant of a, so we will just copy paste here. In the numerator also we have the similar kind, but in terms of x we have c1 b2 minus b2 b1 c2. So c1 b2 minus c2 b1. c1 b2 minus b1 c2. So c1 b2 minus b1 c2 upon this value of the determinant, and the second one will be also same, but we are replacing the columns there. So let me just copy this again, entire thing. Denominator is same, we will just replace the numerators there. This denominator is same, and this becomes a1, a1 c2 minus a2 c1. So a1 c2, so this will be a1 c2, right? a1 c2 minus a2 c1, correct? a1 c2 minus a2 c1 and divided by the determinant, and then this will calculate. Now first it will check whether the determinant is equals to 0. If it is 0, then it will give this. If not, then it will execute this. And once we have this, let us print the solution, right? So print, let us tell the user that the solution is something like this. The solutions by using Cramers rule are, let us print the values of x and y. So print we will put x equals to So that x equals to, we need to put that in the comments. So x equals to, then we'll put the value of x, right? And then again we'll put y equals to comma y. This will give the values of x and y. This will print the values of x and y. Let's see. But it should not give any error. Yeah. So enter the coefficients of the following in the following format. This we got values of a1. Let's go back with the same equations what we had earlier. It was 2 4 3, 2 4 3, and then 6 7 2, 6 7 and 2. The equations entered are this. The solutions by using Cramers rules are this. The name y is not defined. Okay, so let's check what is the error. This is the problem when we copy paste the work, because we have copy pasted this but we have not changed this to x to y. So let us change this to y, otherwise we might have got the error. Now I think it should give. Recall it was 2 4 3 and it was 6 7 and something, 6 7 and this is 2. The equations entered are this. The solutions by using Cramer's rule is x equals to minus 1.3 and y is equals to 1 by 1.4. And when we calculated, we got the values of x and y as this. So divided by 10, that means it is 1.3 and this minus 10. So x is equals to minus 1.3. That's correct. And when when we have this is nothing but 14 upon 10, that is 1.4. So this is 1.4. Okay. So what it does is it will first calculate the determinant. If determinant is equals to 0, then the solution will exist. Not equals to 0, then the solution will exist, and it will calculate by using Cramer's rule. Otherwise, the Cramer's rule cannot be applied. Okay. Let us take a system wherein the determinant will be 0. So we need to write, or we need to have the system wherein we have the determinant equal to 0. Okay. So determinant will be 2 into 2, 2 into 1. Okay, let me write this one. 2x plus 4y is equals to something, no problem, anything. And a2, so that 4 into 1, so 1, and 2 into 2, 4, and 20. So if you see, the equations entered are this. The determinant of the coefficient matrix is 0, because when you have 2 into 2, 4 minus 4, 4 minus 4 becomes 0, and hence the Cramer's rule cannot be applied, and the program will terminate. Okay. So in the program, if you see, it will execute this. Since this is correct, this will be skipped. Okay, this is correct, so this everything is skipped, and we got this. Now this I don't know how to pronounce it, and then done something are important. So if you take this like this, see, you can see the difference. You can give the random 1 2 3 4 5 and 6. See. Okay. So you can play around with this code, and you can learn this by yourself. You can check if you take input as an integer, what are the different changes. In some cases you may not have a solution in integer. Okay. So if you are interested to get the integer solution of some equations, those equations, that entire thing is called type and 10 equation. Right? For example, if you want to find the solution of ax plus by is equals to c, or for example here 2x plus 4y equals to 3. If you need to find the integer solution, then that thing, whatever full process is called Diophant-Ten equation. In short, Diophant-Ten equations are interested in finding the integer solution. Okay. If you are done with this, you can skip this, and if you are interested in another theory, just continue for 1 or 2 minutes. Now, when we have two equations, two unknowns, say for example, ax plus by is equals to c, and let us take something px plus qy is equals to r. These are two equations to unknowns. Now if you see, this is the equation of a straight line, right? This is again the equation of a straight line. So if somebody asks you how many, if this equations has two solutions or 10 solutions, but remember, it cannot have these kind of solutions. No system will have two solutions or three solutions. Why? The reason of this is because it is like those are the straight lines. These both the equations represent the straight lines in xy plane. Now the possibilities for straight lines are either the two straight lines are parallel, that means they will not intersect anywhere, that means it will not have any solution. Okay, if you have two equations which are parallel, two straight lines which are parallel, it will not intersect anywhere, right? The point of intersection is the solution, right? Those points will satisfy both the equations and that is the solution. Another case is they are intersecting, somewhere they will intersect. So one equation may be like this, another equation may be like this, and this is the point of intersection, and this is a unique solution, right? Two straight lines will intersect. If they are intersecting, they will intersect at a single point. And third case, if we have two lines which are overlapping, right? So you may have one line like this, and again on the second line will be same on this only. In that case, you will have infinitely many solutions, because you will take any point. If you take any point on this line, it will satisfy the it will intersect the other line, right? So in this case, you will have infinite solution. This case you will have unique solution, and in this case you will have no solution, right? So hence you cannot have a system where you will have exactly two solutions, right? That is a general knowledge kind of question. So this is all about today's things. We have learned, we have written a program for Cramers rule by using Python. As I said, we have used this formula. Okay, we can write the program for finding the solution of the three equations in three unknowns by using the similar formula. Okay, if you are done, you can put in the comment.